Hello, my name is Jamal Imam.
And I am Nizamuddin. My name is Faisal Ahmad Julendo.
And I am Inertia. And I Ikman. This is the design for our catapult. We have built it from just wood and using a rubber band string with the hinges. The length for this catapult is 50 centimeters. The width is 24 centimeters and the height is 30 centimeters. Okay, our angle, the angle of the catapult is fixed at the theta. The range is measured from the positive x-axis, it's 30 degrees.
The design of our project, catapult, is inspired from the movie Chronicles of Narnia.
The part where the catapult is used in the movie is when Phil Caspian tries to take down the lion. He puts a stone into the catapult and launches it at the lion, attempting to kill it. Okay, while seeing the movie, we come up with we wanted to see how the catapult would work in real life, so we decided to try and build it and see how the physics, the calculations would work with it as well.
Okay, for the maths behind the machine, the main formula we are using is R is equal to V naught squared sine 2 theta over G, which is the basic projectile motion formula, where R is the range, V naught is the initial velocity, theta is the angle of launch at which the golf ball will launch, and G is the gravity. From this formula, we will have to calculate the V naught, the value of V naught from our energy formulas. So from the energy formulas, elastic energy is equal to potential energy plus kinetic energy. Elastic energy, the formula is half kx squared, in which k is the spring constant, x is the spring extension. Okay. The potential energy is mgh and the kinetic energy is half mv naught squared. Okay, equating all these formulas together, we will get a final answer of v naught is equals to root of half kx squared minus mgh over half m. Okay, now this is the formula for v naught, the initial velocity. So what we will do is we're going to substitute the value of v naught into the initial projectile motion formula, which is R is equals to V naught squared sine 2 theta. So the final answer, when V naught is substituted into the basic projectile motion formula, we will get R is equals to this formula, this equation. Okay, in this equation, we will have to make the spring constant, which is x, the subject of the formula. So since we already know the ranges are fixed, we will have to make the spring constant the subject of the formula. The value of x as the subject of the formula is root on 2 over the spring constant rmg minus mgh over sine 2 theta. The initial length of the spring is 32 centimeters. How to calculate the spring constant is we have used dumbbells, because dumbbells have fixed mass. So we have come up with 3 different masses. One of the dumbbells is 1 kg, the other one is 1.5 kg, and the last one is 2 kg. Okay, from this we have come up with a table of values for the number of force. Force is calculated by mass of each dumbbell multiplied by how long the spring extends. So F and X. So using the Hooke's law, which is F is equal to Kx, making K the subject of the formula, we got F on the change in X. So the change in F is 14.715 minus 9.81, the change in the force, divided by the change in the spring extension, which is the slope of the graph. And we got a spring constant of 61.325 Newton per meter.
And there's just no turning back when your heart's under attack. Gonna give everything